We start with calculus. So far we have seen differentiation in detail, correct? We have seen differentiation. Differentiation of what? We have seen differentiation of single variable functions. That is, we have seen of functions of type y is equal to f of x. That is one dependent and one independent variable. We have seen functions of this type. But in the real world we have multivariable functions also. Multivariable functions. What do I mean by multivariable functions? For example, I can say z is a function of x and y. Here we have two independent and one dependent variable. Correct? So we have multiple independent variables. That means, what do I mean by this exactly? If I have to write it in English language, what it means? Z depends on x and y. Okay? So if I go on analyzing this statement, what I get? Any variation in x or y. I am very carefully using the words here. It is or. Any variation in x or y. That means x changes or y changes, there will be change in z. Correct? Now again I came from this statement to this statement. Let me go step by step. Let me form further statements from this statement. Means what? Because of change in x, there will be a change in z. Similarly, because of change in y, there will be a change in z. Correct? Okay. Let us stop this here. We will continue back. Okay, we will come back to the same point. Okay. Let us stop here and see what we have seen earlier. We will capture some results and come back to the same point. What do we say? Let me take, let g of x be a single variable function. Then what is g dash of x? This is nothing but, we have seen from class 1, limit s tends to 0 of x plus h minus g of x by h. Correct? This is what we have been seeing. Okay? Now let us come back to our x. Let us come back. We have z is equal to f of x comma y. Okay? Then what do we mean by z is a function of x and y? Then what do we mean by dz? Dz means what? I am differentiating f dash of xy. What do we mean by this? Going by this, let me call this as 1. Going by 1, what do we get? F dash, that is my dz, is same as f dash of x comma y. That is nothing but, there is a small change in x, small change in y, minus f of x comma y by h. For a small change in x and y, what is the change in f? That is what we are doing. Here what again we have that limit h tends to 0 here. So the assumption we are doing this is both x and y are changing. But if we come back, what we saw, even if y is not changing, because this is r, correct? I first itself I marked this word r and kept. That means x changes, even y is not changing, then again I will have a change in z. Similarly y is changing, and x is not changing, again I will have a change in z. So how do I capture that? I can have also a change in z. There can be, let us write that, there can be change in z due to x alone. Something like f of limit h tends to 0 x plus h comma y minus f of x comma y by h, or there can be change in z due to y alone. This is also possible, right? This is what we have been saying from the starting of this class. I am saying the same statement in different using different words. So if I write this mathematically, how it will look? Limit h tends to 0 f of x comma y plus h. There is variation in y alone, there is no variation in x, divided by h. Correct? So if I box this and call this as a, if I box this and call this one as b, a gives change in z due to x alone, and b gives change in z due to y alone. Observe that when I am saying x alone, the y, here also it is y, here also it is y. Please note where I am marking. Here also it is y, here also it is y. Similarly, when there is change due to y alone, here x is not changing, here also it is x. Please note the marker, here also it is x. Whereas the y plus h is becoming y here in this case. In the a case of a, x plus h is becoming x. Correct? Thus, we saw that there is change in z due to x alone. There is change in z due to y alone. And this, I call this as dou z by dou x. And this I call it as dou z by dou y. That is, these are called partial derivatives. And what is dz? Dz is the net change in z. And what will be the net change in z? It will be the sum of change due to x alone and due to y alone. Correct? This is something like your individual marks, and this is something like your total marks. Correct? Something like that. So dz is nothing but dou f by or dou z by dou x times dx plus dou f by dou z by dou y times dy. This is the change due to y, and this is the difference change in y. This is the change due to x, and this is the change in x itself. Remember, we do function of function rule, we do chain rule, right? What is differentiation of cos x? Differentiation of cos x, we write it as minus sin x dx, right? This is change in the function, this is the change in the variable, like that. This is the change in the function due to x alone, and this is the change in the variable. Similarly, this is the change in the function due to y alone, and this is the change in the variable y. This is a very important conclusion, and we will tabulate and keep this result. This is a very important result. Clear? So we summarize. What we have seen. Point number 1, in case of multi-variable functions, there will be change in the function due to every independent variable change, and this change in the function due to change in one independent variable is called partial derivative, and third point is net change in the function is the sum of all the partial derivatives with okay, this is the concluding remarks we have. Okay, please remember this. Take an example. And analyze. Say f of x y is given by xy minus x square plus y square minus 2x. Okay, find change in function f due to x alone, y alone. When I am saying with respect to x alone, I treat y as constant. That is, x alone is varying, y is not varying. It's like a constant. Similarly, when I say y alone, I treat x is constant and y alone is varying. This is the understanding. So ultimately the question is to find what is dou f by dou x and what is dou f by dou y. This is what is asked. So what is dou f by dou x? Dou f by dou x is nothing but differentiate the function f treating y as constant. This is nothing but differentiate function f treating y as constant. This is function f. Means what? Means what? I dou f by dou x is nothing but I treat y as constant, so I get y into differentiation of x will give me 1 minus differentiation of x square will give me 2x plus pure y square is a pure y term, so y is like a constant, so constant on differentiation will give me 0 because y square will change with respect to y only, it will not change due to x, minus 2x on differentiation with respect to x will give me 2. This is nothing but y minus 2x minus 2. Similarly, dou f by dou y is differentiate function f treating x as constant. When I do that, what I get? I will get dou f by dou y, is equal to x square on the first thing is xy on differentiation with respect to y will give me xy on differentiation with respect to y will give me x, and x square is a pure x term, there will be no change due to y, so that will give me a 0, plus y square is a pure y term, so that on differentiation with respect to y will give me 2, and minus 2x is a pure x term, so that on differentiation with respect to y will give me 0, so the answer will be x plus 2y. Okay, we were discussing about partial derivatives. Let us continue the same. Let us solve one more problem to strengthen our understanding. F of x comma y is equal to x cube plus y cube plus 3x square y plus 3xy square plus 2x square y square. Find dou f by dou y, dou f by dou x, dou square f by dou x square, dou square f by dou y square. Now these two I have added newly. Now let us understand first what we mean by this and then proceed. Okay, so what is dou f? First of all, we have not seen one thing. Let us understand that. This is a very good point to understand. Let us understand at least now. We have dou f by dou x. For that matter, let us take some function g of x. Let g of x be some function. We have d of g of x by dx. We have d square g of x by dx square. We have d by dx of g of x, this the whole square. Are these two same? Similarly, we have, with respect to this question, I want to ask, we have dou square f by dou x square. Is it same as dou f by dou x the whole square? Are these two same? The answer is a big no. Please don't even commit this mistake of saying yes. This is very important to remember. See, differentiation, whether it is a partial derivative or a complete derivative, it is an operation. Okay, operation means what? You think, you understand it this way. It is very good to understand this way. It is nothing but a mathematical machine. Okay, now what do you mean by dou square by dou x square or d square by dx square for that matter? We have the operation done twice. This is like the mathematical machine. This is like a mathematical math machine. There is d by dx. There is d by dx. I feed the input here and I take the output here. If I put one block, I get d by dx. I do twice, I get this. Whereas I can do, if I can do this, I can do this also, right? I can do d by dx. This is the function. Input is what? Input I supply f of x or g of x, whatever you want to call. I supply a input is a function. I am supplying a function as the input. Similarly, I can supply a function here and I can do d by dx and I can take this and multiply here. Correct? This is what I do when I do d by dx the whole square. This and this are definitely not same. They are not same. Here I am doing the operation twice. The output of the first is the input to the second, whereas here the first output and the second output are collected separately and multiplied. So d square and d, this is a big no. Please remember this. This is not at all possible. This is not at all possible. Please remember that. Okay. Okay, now back to problem. What is my f of xy? F of xy is x cube plus y cube plus 3x square y plus 3xy square plus 2x square y square. So first let us start with dou f by dou y. What is dou f by dou y? Change. Let us write this couple of times so that it gets registered in our mind. Change in f due to y only. That is, when I say y only, x is constant. Okay, so x cube is a pure x term. If it's a constant, there will be no change. So on derivative it will give me 0. Y cube will give me 3y square plus 3x square y will give me 3x square, because y I am differentiating with respect to y. Similarly 3x is a constant for me. I differentiate y square now. So I get 3x into 2y plus 2x square is a constant term and I get 2y. When I simplify this, we get 3y square plus 3x square plus 6xy plus 4 x square y. This is what I get. Correct? So what is dou square f by dou y square? This is nothing but dou by dou y of dou f by dou y. This is nothing but I am differentiating that's what we are doing, right? This is not multiplying, this is operation. This is operation, not multiplication. Okay, not multiplication. Please remember. Multiplication is different, mathematical operation is different. Correct? See, for example, what I mean is sine of x, I say it is not sine multiplied by x. Correct? It is the variable x operated by a function sine. Correct? Like that only it is. It is a variable dou f by dou y operated by dou y. Correct? So it is not multiplication here. Okay? So now when I do this, I have to differentiate the dou f by dou y with respect to y. So I have already dou f by dou y here. When I differentiate it with respect to y again, I will take first these terms and differentiate it. So 3y square will give me 6y. Then 3x square is a pure x term, so I will get a 0 plus 6xy will give me 6 into 1 plus 4x square y will give me 4x square. So the result will be 6y plus 6x plus 4x square. This is my dou square f by dou y square. So we have seen dou square f by dou y square. We found dou f by dou y. From there we calculated dou square f by dou y square. And how we did it? It is nothing but dou by dou y of dou f by dou y. This is cascaded operation. Like I drew in the diagram. First we took f and did the operation of dou by dou y. Then on its result we again did a dou by dou y and we got dou square f by dou y square. This is cascaded operation. This is like a cascaded operation, correct? It's not multiplication. Please remember this. I am repeating it so that it gets registered in our mind. It is not multiplication. Okay, now let us go back. F of xy, what was given? X cube plus y cube plus 3x square y plus 3xy square plus 2x square y square. Correct? Okay, now we have to find dou f by dou x. What is dou f by dou x? Change in f with respect to x only, means y is a constant. Means what? When I differentiate, this is a term containing x, so I will get 3x square. Y cube is a pure y term. Y cube is a pure y term, so y is a constant, means like a 0. 3x square y will give me 6x y plus 3y square plus 4x square y square. 4xy. This is what I will get. xy square. Okay. This is what is dou f by dou x. So from this, what is dou square f by dou x square? It is nothing but dou by dou x of dou f by dou x. Remember, it's not multiplication, it's back to back operation. So this, I take the result of dou f by dou x and apply another derivative there. I do the operation once again. That is, I get 6x plus 6xy will give me 6y plus 3y square is a pure y term, it will go off. 4x square y will get 4x. I'll get 4y square. I'll get 4y square. This is the answer. I leave the algebraic simplification to you guys. Okay, this is the answer. We have found all the 4 terms, right? We are asked to find dou f by dou x. We found dou f by dou y. found dou f by dou y square, dou square f by dou x square. All the 4 terms we have found. So we are done. Okay. Now let us take another problem, or rather a same problem. We will try to find something different. And through this problem we will understand some concepts also. X cube plus y cube plus 3x square y plus 3xy square plus 2x square y square. This is what we were solving, right? Now let us find what is dou square f by dou x dou y and dou square f by dou y dou x. Find this. Now what do we mean by this? This is the first time we are seeing something like this. Correct? What do we mean by this? Again, going back to the same analogy of a machine, analogy of a mathematical machine. What do I mean is dou square f by dou x dou y means what? I take f and give as an input to this machine. I do dou by dou x first, and on this result I do a dou by dou y and get the result as dou square f by dou x. I'm sorry, this is nothing but this. I get dou y dou x. What? First I operate it with respect to x, then I operate it with respect to y. This is y here. So dou square f by dou x dou y is nothing but dou by dou x of dou f by dou y. Similarly, dou by dou y of dou by dou f by dou x, nothing but dou square f by dou y dou x. Clear? Okay. Now, having understood this, let us find this. So we have already calculated in the previous problem dou f by dou x is equal to 3x square plus 6xy plus 3y square plus 4xy square. Now I have to find dou square f by dou y dou x. This is nothing but dou by dou y of dou f by dou x. This is nothing but I have to differentiate with this term with respect to y now. So 3x square on differentiation with respect to partial differentiation will give me 0, plus 6xy on partial differentiation with respect to y will give me 6x, 3y square will give me 6y, and 4y square will give me 8xy. 8xy. This is the answer. Clear? Okay. Okay. We have find dou square f by dou x dou y. Let us find what is dou square f by dou x dou y. Okay, and let us see whether are they similar. What is this? This is nothing but dou by dou x of dou f by dou y, and we have already calculated dou f by dou y in our problem. Dou f by dou y we calculated as 3y square plus 3x square plus 6xy plus 4x square y. We calculated already for the sake of previous problem. Now we have to differentiate these terms with respect to x again. Okay, so what we will get, 3y square on differentiation with respect to x will give me 0, because I am doing a partial derivative, I consider only change in x. 3x square will give me 6x plus 6xy will give me 6y, and 4x square y will give me 8xy. We observe that we are getting same answer. Okay. Okay. So we were seeing about partial derivatives, and we were talking about higher order partial derivatives, right? We were talking about higher order partial derivatives. That is, we were talking of something called dou square f by dou x square, dou square f by dou y square. We are also talking of a special case of dou square f dou x dou y and dou square f by dou y dou x. Okay, so now I am a bit lazy in writing, so let me introduce some notations to write these things. I call dou f by dou x, from it's just a notation many books follow, even I will like to follow it for sake of simplicity in writing. I will call this as fx. Similarly, dou f by dou y, I will like to call it as fy, f suffix y. So similarly, dou square f by dou x square, I will like to call it as fxx. Dou square f by dou y square, I will call it as fyy. So this, no surprises or no prices for guessing, it will be fxy, and this will be fyx. These are just notations, okay, notations used. This is used in many books also, so let us use the same notations. Okay. Now, after doing all these things, what is the ultimate conclusion where we are heading to? What is the use of doing all these things? Am I solving all these things just I have no portion to complete, or is there any meaning out of this? That is more important thing we should understand. Okay, so yes, the application of partial derivative, that's what I mean in short. Application, this is where we are most interested as engineers. Okay, so what is the application? The application is finding the maxima or minima of multi-variable functions, because in real term we will have multi-variable function, and to find the maxima or minima of that point of the functions, we need to use partial derivatives. There are some conditions for that. So let us recall quickly. We can recall what we did for single variable function. Single variable function, what we did, we can quickly recall. We did f dash of x is equal to 0, then f double dash of x less than 0 means maxima, f double dash of x greater than 0 means minimum point, correct? So this is for single variable functions. For two variable functions, what it is, let us understand this. For two variable functions, how it will look like. Now we say that again the same thing, fx is 0, fy is 0. Okay, that is dou f by dou x, for the sake of understanding I am writing, is equal to 0. Dou f by dou y is equal to 0. Okay, at some point. This is the starting place. Here we had f dash of x equal to 0. Here we have fx equal to 0, fy equal to 0. This is the starting point. Then with this we cannot conclude anything. Here also we were not able to conclude anything, right? In this case it can be a maximum or minimum. We went ahead and inspected the second derivative. Similarly here again in two variable case we are going to go ahead and inspect the second derivatives. Then we say that fxx is less than 0 and fyy less than 0 and fxx, it is not so straightforward here, minus fxx into fyy minus fxy the whole square is greater than 0. If all these are satisfied, I call this as maxima. Similarly, fxx is greater than 0, fyy is greater than 0 and fxx into fyy minus fxy the whole square is greater than 0, then it is called minima. At that point the function is having a maximum value, and at this point the function is having a minimum value. Okay. And there are three cases here. We have investigated case A, case B, now case C. If observe that in both the case A and case B I have written for this thing is greater than 0 in both the cases. Okay, and if fxx into fyy minus fxy, it's not f of xy, it is fxy the whole square, if it is less than 0, then we call it as a saddle point. And third last point I want to make, that means here I don't get maxima, or that means in case C we don't get either a maximum or a minimum. Please remember that. Third case, we call this fxx into fyy minus fxy the whole square by a special name called discriminant. Please remember that this is referred as the discriminant.